What's up, everybody? It's Dan from SageMathTutoring.com, and here I have a video covering some problems for one of my eighth grade tutoring students. She has an exam coming up, and this is a practice test. So, looking at problem number. So, this is a matter of simplifying this expression. Now, when you're simplifying expressions, you're going to want to use PEMDAS. And PEMDAS suggests that you should always simplify anything inside parentheses first before you do anything else. And then after that, look to see if you can apply an exponent. After that, look to see if you can do multiplication or division. After that, look to see if you can do addition or subtraction. Now, it is the case that multiplication and division are interchangeable in the sense that if division comes first, you could actually do that before multiplication. And addition and subtraction are also interchangeable, which means that if subtraction comes first, you could do that. So anyway, clearly there's no parentheses, there's no exponents here, but there is an opportunity to do division. Now, the question is, what is 6 divided by 1/3? 6 divided by 1/3. Well, in this case, we could do that trick called keep, change, flip, because the reality is that 6 secretly has a 1 underneath it, so we could keep that, and we could change this to multiplication and then flip the fraction. So that's going to become 18. So the reality is that this part right here is 18. Now, you might be tempted to go ahead and add, but remember, we have an opportunity to multiply here, which means, according to PEMDAS, you have to do that before you add. So the question at this point is, what is 2/3 times 9? So we're going to say 2/3 times 9. 9 secretly has a 1 underneath it. I'm going to say, let's go ahead and cancel the 9, turn it into a 3, cancel this 3, turn it into a 1. And then at that point, you can multiply straight across. You have 2 times 3, which is 6. So really, it's going to be 18 over there and a 6 there, and then we're going to be adding those, and that's 24 clearly. All right, so that's that one. Problem number 210, if x equals blah, 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 y equals blah, blah, z equals that, the value of all that stuff is, well, you're going to want to just substitute in the values. I would say use empty parentheses for the variables, and then fill them in. So x is -3, so that goes here. Y is 5, so that goes here. And z is -2, so that goes there. Now, according to PEMDAS, we should be simplifying that which is inside the parentheses first. So what we're going to do is we're going to leave the -3 out there, and we're going to say, okay, well, what is 5 minus -2? Well, that's the same as 5 plus 2, which is the same as 7. So then we have 7 squared. According to PEMDAS, we should apply the exponent at this point. So it's going to be 7 squared, which is 49. And it's, 49 times that -3. According to PEMDAS, we can now do multiplication. So -3 times 49 is, well, certainly going to be negative, and it's going to be like sort of a large negative number, so it's that one. 7 is to 21 as 2/3 is to, okay, so what I would say for this, anytime they say is to, like something is to something as something is to something, I would set up a proportion. So we have 7 over 21 equals 2/3 over x. And the way that you could read this is 7 is to 21 as 2/3 is to x. Now, at this point, we could also recognize that 7 over 21 reduces to 1/3. So we have 1/3 equals 2/3 over x. Now, at this point, we could do something called cross multiplication. Cross multiplication means we're going to multiply these two and find out what that is, and we're going to multiply these two and find out what that is. And at the end of the day, we're looking at 1 times x, which is just x, and then it's going to be 3 times 2/3. Now let's analyze that situation. The reality is there's an invisible 1 underneath that 3, which means that in a way you could think of it as a fraction times a fraction, and the 3's would cancel. So this 3 cancels with that 3, and then we have x equals, these turn into 1s as a result. So x equals 2, so that's the answer there, unless I made a careless mistake, which I don't think I did. All right, solve 63 divided by 1/9. So 63 divided by 1/9, well, secretly 63 is 63 over 1. We could do keep, change, flip, so we have 63 over 1 times 9 over 1, and then in a way, I guess we could ignore the ones on the bottom. So the real question is, what is 63 times 9? Well, we know it's a large number, so it's going to be D. Solve 72.61 divided by blah, blah, blah. Okay, so that's long division, so we could do 72.61 divided by 0.05, but the thing is, you're not allowed to have a decimal as the divisor, so that means we're going to have to move that twice to the right, which means we have to move this twice to the right, which means that the real problem we're asking ourselves is what is 7,261 divided by 5. So 5 goes into 7 once, so you can put a 1 there, put a 5 here, 1 times 5, and then 7 minus 5 is 2. Drop this 2 down right here. 5 goes into 22 4 times. We have 20. 22 minus 20 is 2. Drop the 6 down. 5 goes into 26 5 times. And that would be 25. And then subtracting 25, we have 1. Drop the 1 down. 5 goes into that thing, twice. And then we're going to have 10. And then we can keep going, but here's the thing. We already know it's 1,452 point something. So we could just say it's this. All right, so that's that. Increase by 150%, the number 72 becomes. So I would suggest using something called the open formula, but it kind of looks like this. All right, now this says original. This is the percentage, as a decimal, by the way, and this is the new amount. So if you take 72, which is the original, you can multiply it by 1, and since it's an increase, it's going to be plus. So we could write plus, and then we have to convert 150% to a decimal. Now, the way you do that is that you move the decimal place twice to the left. So we're going to say 1.5 right there, and that's going to equal the new. So at the end of the day, this is going to be 72 times 2.5, and that's going to equal the new. Now 72 times 2.5 is 180. So what did you need to know for this one? You needed to know, first of all, this formula here, the original times 1 plus or minus p equals n. Now the O stands for original, p stands for the percentage as a decimal, and n stands for new. You also needed to know that if it's a decrease, it's going to be minus. If it's an increase, it's going to be plus. We also needed to know that in order to put the proper number into the percentage position, you have to convert the percent to a decimal. That's a matter of moving the decimal twice to the left. So you did need to know that. And at that point, of course, you need to work all this out. All right, so that's how you do that one. Looking at problem number 219. Class is voting for a class president and class vice president. If there are 10 students running for president, 7 students running for vice president, how many different combinations of president and vice president are possible? So the way I like to kind of think about these is here's the choice of president, here's the choice of vice president. How many possibilities are there for president? Well, 10. How many possibilities are there for vice president? Well, there's 7 because there's 7 who are running specifically for that position. There's no overlap between these categories. So all you have to do actually is just multiply straight across. That's called the fundamental counting principle. And there are 70 possible combinations for that. Okay, looking at problem number 220, a rectangle has length of x plus 3, width of x minus 1. If x equals 2, what's the perimeter of the rectangle? So we have a rectangle, we'll call this x plus 3, we'll call this x minus 1, x equals 2, so clearly we're looking at 2 plus 3, which is 5. Clearly we're looking at 2 minus 1, which is 1. Now, if they want the perimeter, we need to realize that this red thing is the same length as this red thing. We already discovered that that's 1, so that's also 1. In order to find the perimeter, we need to realize that this blue thing is the same length as this blue thing, and we already discovered that that blue thing is 5, so that makes that 5. Now, the reason I'm saying that is because the perimeter is a matter of adding all these values all the way around. It's going to be 5 plus 1, which is 6, plus another 5, which is 11, plus another 1, which is 12, so that's the answer there. Problem number 223, a legend on a trail map indicates that 1.2 inches represents 50 feet. How many feet is represented by 6? Well, I would do a proportion here. We could say inches over feet. So just make that decision. It could have been feet over inches, but we're going to do inches over feet. So we have 1.2 apparently corresponds with 50 feet. So therefore, we want to know how many feet is represented with 6. So you could set up this thing. So notice inches corresponds with that many feet. So we have 6 inches. So how many feet is that? You set up this proportion. Now, like I said before, you can do a cross multiplication here. So you have cross multiplication, cross multiplication. So 1.2 times, x is literally just 1.2x. 50 times 6 is 300. Then you'd have to divide both sides by 1.2, and that's 250. So that's the answer there. Problem 224. A department store marks up its clothing 75% over cost. If it sells khaki pants for 17, how much did the store pay for them? Okay, so that is once again the open formula. So if it's a markup, it's going to be original 1 plus P equals the new amount. So once again, original amount, percentage, new amount. So the original amount is the mystery this time because we don't know how much the store paid for them. So basically, for my student watching, stores like retail stores like the Gap or Zara or Macy's or whatever, right? They purchased their clothes from like a warehouse, and that's the original amount they pay. And then they tack on a percentage of profit on top of that, and then they sell it for the new price. Okay, so in case that's not clear. So looking at this problem, clearly we need to know what is the original. So it's the original that's the mystery. So it's going to be original plus 1 times 1 plus whatever that percentage is. Now remember, with the percentage, we've got to move that over. So it's going to be 0.75. And that's going to equal the new. Now we already know the new amount. They're selling the khaki pants for $17. So there it is. So we have 1.75 equals 17. Now at this point, you can divide both sides by 1.75 and you will get 9.714, blah, blah, blah. So it's that. Okay. The area of the figure above is, okay. So in order to find the area of this thing, probably you should, okay, the smartest way, in my opinion, is to take the area of the whole rectangle and then subtract away this part. And then you're going to have the area of the whole of we could say the shaded region, the red shaded region, right? So if we took the area of the whole thing and then subtract the little indentation, then we would be good to go. So I'm going to represent it as this sort of model that looks like this, right? And this is the answer at the end of the day. So the area of the whole thing is going to be, 14 times 10, 14 times 10, which is clearly 140. And the area of this region here is going to be 6 times 6, 6 times 6, which is 36. So all we have to do is say, okay, 140 minus 36, that is 104. All right. So let's see. It's right here. All right, moving on. Okay, so as a train departs from station A, it has 12 empty seats, 14 seated passengers. So already we know that there are 26 seats just based off of that information. Because if there's 12 empty and 14 seated, well, doesn't it make sense that there has to be 12 plus 14 seats? I think, right? Pretty sure. So 26 seats. And we have 4 standing passengers. So what that means is we had 26 seats, but there were also an extra 4 passengers. So in the beginning, we could say, in the beginning, there were 14 plus 4 people. So there were 18 people in general, right? Because there were 4 standing passengers and 14 seated passengers. So there were 18 people in the beginning. At the next stop, 8 passengers got off, 13 passengers got on. So it's 18 minus 8 plus 13. So we're going to have 23 people, right? 23 people. And then there are therefore 23 people now on the train, right? And then they say everyone takes a seat. So all 23 people take a seat. How many empty seats are there? Well, there's 23 people, and literally all the people decide to take a seat. Then there's got to be 3 empty seats left because there's 26 total seats. All right, so rewind that, watch it over and over again if you have to understand that one. Okay, so looking at this one here, there might be a temptation to be like 5 gallons minus 1 gallon, but we have 2 quarts minus 3 quarts, so interesting. Okay, so the reality is that there are 2 pints in every quart. There are 4 quarts in every gallon. So really, what we're dealing with is an interesting situation. So we have 5 gallons, 2 quarts, and 1 pint. So I'm sort of tempted to draw a thing where this box represents a gallon, okay? Each quarter represents a quart, all right? And each quart has 2 pints, all right? So, I don't know, is this good? That's a pint. 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 So it's obvious that there are 8 pints for every gallon. I mean, we could have just used math for that. So there are 8 pints for every gallon. I think that's going to be our ticket. Every gallon is equal to 8 pints, and every quart is equal to 2 pints. So why don't we put everything in terms of pints? Because that's the smaller unit. So 2 quarts is secretly 4 pints, right? 3 quarts is secretly 3 times 2, which is 6 pints. 5 gallons, there's 8 pints in that, so that's going to be 8 times 5, which is 40 pints. And then we have 1 gallon here, which is 1 times 8, which is 8 pints. Now I'm thinking, why don't we just add up all the pints in the first quantity? It's going to be 44. It's really 45 pints. And it's going to be 45 pints minus 8 pints, but it's 45 pints minus 14 pints, right? Because it's 8 pints plus 6 pints. So we could do 45 pints minus 14 pints, and that's going to be 5 minus 4 is 1. 4 minus 1 is 3. So the question is, which one of the answer choices represents 31 pints? Well, I'm thinking there's that 1 right there, so I'm thinking it's probably first 3 because it has that sort of 1 pint extra thing. So let's see which one actually matches. So 9 quarts, there are 2 pints for every quart, so that would be 18 pints plus 4 times 8, which is 32. So that's already too much, right? 32 plus 18 pints plus 1 pint is more than 31 pints. Let's look at this one. Let's go in this direction. 2 times 8 pints is 16 pints, plus 2 times 2 pints is 4, so we have 16 pints. So this would give us 21 total pints, and that's not enough. So I'm really thinking it's got to be this one. 3 times 8 pints is 24 pints, and 3 times 2 pints is 6 pints. So we have 24 pints plus 6 pints plus the extra 1 pint, that's 31 pints. So that's a tough one. All right, that's kind of a tough one. All right, looking at problem number 232, number of phones and blah, blah, blah is 48,000. If this represents 2.8 phones per 100 person, the population to the nearest thousands is what? So I would say that's also a proportion problem in the sense that we could put phones over population. So we know that there are 12.8 of phones for every 100. And we also know that there are 48,000 phones, so that belongs on the top. And the mystery is how many people correspond with 48,000 phones. Well, once again, you could cross multiply, right? You could cross multiply. And that's going to be, we'll bring it over here, 12.8x equals 48,000 times 100. Now, anytime you multiply a number by 100, you just put 2 extra zeros on it. So instead of 3 zeros, it's going to be 5 zeros. So it's going to be 4, 8, 1, 2, 3, 4, 5. And then you could do your commas after that. So it's 4,800,000. So at this point, we can divide both sides by 12.8, and that would be 375,000. All right, so that is this one. All right, problem number 233. A carpenter needs 4 boards, each 2 feet 9 inches long. If the wood is sold only by the foot, how many feet must he buy? So how many feet must he buy? Let's see. So that's going to be he needs 4 of these boards, so it's going to be 4 times, 2 feet 9 inches, right? So that's going to definitely be 8 feet and 36 inches, right? Now 36 inches is 3 times 12 inches, and it is the case that there are 12 inches in a foot. So in reality, this is 3 times 1 foot. So it's really 3 extra feet here. So this 36 inches is 3 extra feet. So we could just say that it's going to be 8 feet plus the 3 extra feet right there. So that's 11 total feet right there. All right, problem number 234. A square has an area of 49 square inches. The number of inches in its perimeter. Okay, so if it's square, it's got 49 inches. So the area of any square is side times side. If you have a square where that's the side length, that's an S, not a 5. Okay. Now, apparently, the area is 49. So apparently, when we did side squared, we got 49. So it stands to reason that the side length is 7. So clearly, we're dealing with a square that has a side length of 7. And we know that because 7 times 7 would give us the area of 49. But they want the perimeter. Now, the perimeter is just a matter of recognizing that this has to be 7, that has to be 7. So it's going to be 7 plus 7 plus 7 plus 7, which is 28, and that's the answer. Problem number 235. Aluminum bronze consists of copper and aluminum, usually in the ratio of 10 to 1 by weight. So 10 corresponds with the copper, 1 corresponds with aluminum. If an object's made of this alloy weighs 77 pounds, how many pounds of aluminum does it contain? Okay, so that's interesting. Okay, let's see. So we want to know how many pounds of aluminum. So we're going to put aluminum over total weight. So in a way, this is a part to whole, where this is a part, there's a whole. This is the first time we had to deal with a part to whole ratio. So the part that we're sort of concerned with is aluminum, but we're kind of also analyzing the total weight. The total weight is 77. So we already know that there's 1 part aluminum corresponding with 10 parts of copper, but that's a total of 11 parts. So we're going to put 11 down here, okay? We're going to put 11 down there. So once again, we have aluminum up top and total weight down below. So that's going to be 11 units of weight, okay? Weight, right? 10 to 1 by weight. So 11 total units of weight. All right, I'm going to use arrows here instead of equal signs right there, because at the end of the day, we're setting up a sort of a proportion over here. And then now we're saying if an object weighs 77, well, that 77 represents the total weight, and we want to know how many pounds of aluminum does it contain, so the X will be up top in this case, because that's the part that we're analyzing, aluminum up top. So the question is, what is X when it comes to that particular proportion? Well, I can already see it's 7, but if you cross multiply, you're going to multiply those, you're going to get 77, and that's going to equal the product of these two, and that's going to equal 11x, and then you divide by 11, x equals 7. All right, so it's 7 pounds. Don't be thrown off by the 7.0. That's just their way of trying to showcase the fact that it's exactly 7. We're not rounding it, or we're at least not rounding it to the nearest whole number. All right, so that's that one. 238. Let's see. A group left on a trip at 8:50 a.m. and reached its destination at 3:30 p.m. How long in hours, minutes did the trip take? Okay. Okay, so I don't know. I mean, 8:50 is 10 minutes away from 9 a.m. So this is kind of the way I want to do it. And clearly 3:30 is 30 minutes after 3 p.m. So my thought is, why don't we just figure out how many hours is it from 9 a.m. to 3 p.m.? Well, clearly it's 3 hours from 9 to 12 noon, and then it's another 3 hours. So this span is 6 hours. So we know we went at least 6 hours. But then we're going to be adding the extra 30 minutes and we're going to be adding the extra 10 minutes, right? Because we didn't start at 9 a.m., we started 10 minutes before that. So it's really 6 hours and 40 minutes, right? So that's the way I would do it. I would keep in mind, okay, 8:50 is really 10 minutes away from 9. That's a nice sort of time to analyze. Um, 3:30 is really 30 minutes after 3 p.m. is a little bit nicer to analyze. Ask yourself, okay, from 9 a.m. to 3 p.m., 6 hours, but I have to add on the extra 10 minutes and add on the extra 30 minutes. Okay, so that is how I would go about that. Hopefully this is helpful, everybody. For my student watching, let me know if you have any questions. And for everyone else, good luck with everything, and I will talk to you later. Bye.